Hey, welcome to a bonus video of adding, subtracting, multiplying, and dividing rational expressions. For the original instructional videos, just look on my channel for the Chapter 8, Section 3, and Chapter 8, Section 4 related videos. Okay, so this is just a bonus video. I added 6 problems here, adding and subtracting rational expressions. So if you're one of my students, you have this paper, you're following along. I encourage you to do these on your own first. If you're not one of my students and maybe you're watching this on your phone, well, hey, thanks for watching, I guess. But here's number 1. You can pause, write it down. Here's number 2. Here's number 3. Here's number 4. Here's number 5. Here's number 6. So I wanted to show you all these because I'm just gonna have these worked out ahead of time, or else this video will be really long. And like I said, it's just kind of a bonus video. There are some problems on the next section, and that is multiplying and dividing rational expressions. If you're one of my students, make sure you've completed these assignments down here. If you're not one of my students, don't worry about that section, obviously. But yeah, here's number 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. Okay, so now I've gotten that all out of the way. I'm going to cut to me explaining all 12 of these, okay? And it'll already be worked out. So number 1, I see that I can factor the denominator of the bottom one. The factors of negative 24 that add up to 5 are positive 8 and negative 3. So I have 12 over x plus 8 times x minus 3. And since the 3 over x minus 3 obviously has an x minus 3 as well, I need to add the x plus 8 to this other fraction. So what you add on bottom, you have to add on the top. And don't forget to distribute. So 3 times x plus 8 makes 3x plus 24. Combine like terms, that makes 3x plus 36. So if I have the bottom factored out, when I get the top, I want to factor that out as well if I can. They have a greatest common factor of 3, so divide each term by 3. That'll leave behind an x plus 12. Nothing ends up canceling, but hey, everything's in factored form on top and on bottom, and x can equal negative 8 or positive 3. So for number 2, well, there's nothing that could be simplified and there's nothing in common, so I took this denominator and I put it on this one. Put it on bottom and top. I took this denominator, I put it on this fraction, bottom and top. And so I distributed 3 times x plus 6 is 3x plus 18. And then if you're minusing, carry that negative with the 1 or whatever number's on top, and then distribute that. So you have negative 1 times x, negative 1 times 4, negative 4. Combine like terms, 3x minus x is 2x. 18 minus 4 is 14. 2x plus 14 could simplify because they're both divisible by 2. So that would leave behind 2 times x plus 7. Nothing would cancel out, but x can equal negative 6 or negative 4 because that would make the bottom go to 0 and you can't divide by 0. Number 3, well, the bottoms both have a greatest common factor. This one has a greatest common factor of 4, so dividing those by 4 leaves behind x plus 3. This one has a greatest common factor of 2. Dividing those by 2 leaves behind an x plus 3. So here I see they have an x plus 3 in common, but there's a 4 on the outside and 2 on the outside, and I need them to be the same number. Well, it just so happens that 2 over 4 simplifies to 1 over 2 because 2 is half of 4. And so when it does that, you do have a greatest, your common denominator, your least common denominator, yeah. And so now you can just add the tops. 1 plus 7 is 8. Well, what's 8 divided by 2? 4. So the final answer is 4 over x plus 3, but x can equal negative 3. So number 4, well, this bottom could factor. The factors of 12 that add up to 7 are 3 and 4. So I wrote x plus 3 times x plus 4. And so here I just rewrote it in black. and this one had an x plus 3 in common with this one. So I just took the x plus 4 from the right fraction, and then I put it on bottom and top in the denominator and numerator. I distributed the 3. I'm not distributing a negative 3 because that negative is behind the 3. So that negative goes to the negative 2x. See, I wrote negative 2x there. So I'm just doing 3 times x, 3 times 4, that's 3x plus 12. 3x minus 2x makes x plus 12, and that's as simplified as it gets. X can equal negative 4 and negative 3 from these two terms on the bottom there, and that's it for that one. So for this one, you have two difference of squares on two different difference of squares patterns. You know it's a difference of squares because it's x squared minus something, and there's no middle term. There's no plus something x in the middle, so it's only two terms. And the thing it's minusing is a perfect square. 36 is a perfect square, 25 is a perfect square, so you know it's a difference of squares. If that number is not a perfect square, then it's not a difference of squares, okay? So the pattern is take the square root, square root of 36 is 6, square root of 25 is 5, make one positive, make one negative. Plus 5, minus 5, plus 6, minus 6. You can also think of it like this. What are your factors of negative 36 that add up to 0 since there's no middle term? Well, that would be 6 and negative 6. What are your factors of negative 25 that add up to 0? That would be 5 and negative 5. They add up to 0, see? And multiply to get negative 25 and negative 36, respectively. So the x minus 6's cancel. The x plus 5's cancel. If you divide by yourself, you're left with 1. So if everything canceled out on top, you have a 1 left, okay? So that's why I have 1 over x plus 6 plus 1 over x minus 5. So I took the denominators from the other fractions and then put them over themselves, all right? And then just doing 1 times x minus 5 makes x minus 5. Doing 1 times x plus 6 makes x plus 6. So combine like terms, x plus x is 2x. Negative 5 plus 6 is 1. So the final answer is 2x plus 1 over x minus 5 times x plus 6, where x can equal 5 or negative 6. On this one, each denominator is factorable. The factors of 12 that add up to 7 were 4 and 3, just like in the last example. The factors of negative 21 that add up to negative 4 are negative 7 and positive 3. Okay, so that's just this in black is just me factoring the denominators. So what do they have in common? An x plus 3. So this fraction needs the x plus 4 that this one has, and this fraction needs the x minus 7 that this one had, okay? So that's why I wrote the x minus 7 and x plus 4 over on each side. So you have to distribute. 3 times x plus 4 is 3x plus 12. Negative 2, again, carry that sign with it. If it's positive, it doesn't matter, but if it's negative, it totally matters. Negative 2x plus 14 now. Add like terms, that makes 26. 3x minus 2x makes x plus 26. And now we have 3 terms on the bottom, 3 binomials. So x plus 4, x minus 7, x plus 3. So can equal negative 4, positive 7, or negative 3, because that'll make it divide by 0. All right, let's move on to the other section now. Okay, so here I'm multiplying, so I don't have to worry about, when you're multiplying or dividing, you don't have to worry about the least common denominator stuff, only when you're adding or subtracting. Just factor when you can. The factors of negative 6 that add up to 1 are positive 3 and negative 2. This is a difference of 2 squares. So again, just take the square root. Square root of 9 is 3, make 1 plus, make 1 minus. Or just think of what are your factors of negative 9 that add up to 0, and that would be positive 3 and negative 3. All right? And so because you're multiplying, just multiply straight across. So they're sharing the top and the bottom. So you can cancel an x minus 2 over here and down there. It just has to be on top and on bottom. It doesn't matter if they're both on top or both on bottom. They can't cancel each other out unless one's on top and one's on bottom. So you see I have multiple, no, I didn't have multiple x plus 3, so never mind. This was an x minus 3. So yeah, everything that cancels out, canceled out. That leaves x over x minus 3. That's as simplified as it would get. But you have these discontinuities where they originally were, so you can't equal 2 or negative 3 or positive 3 because you would have been dividing by 0. All right, let's move on. This one, you have 4 factorable terms. All right, so x squared plus 3x minus 4, factors of negative 4 that add up to 3 are 4 and negative 1. Factors of 4 that add up to 4 are 2 and 2. This has the greatest common factor. There's no third term, so it's not like factors of 2 or 4 that add up to 2 or whatever. So 2x squared plus 4x, they have a 2x in common. Divide that out. That leaves behind x plus 2. Factors of 3 that add to -4, -3, -1. So let's cancel everything we have in common. I see that I have one x plus 2 on top, and I have two x plus 2's on bottom. Don't make the mistake of canceling them both out. You need two x plus 2's on top if you're going to cancel out two x plus 2's on bottom, okay? So it only cancels out one of them. The x minus 1's go. That leaves behind 2x and x plus 4, so 2x times x plus 4. And then an x plus 2x minus 3. And then before you canceled anything out, take into account what x couldn't equal. You cannot plug in a -2 there, or a +3, or a +1. So that's how I got all that. All right, let's move on to the next one. This one was pretty short and sweet. If you're multiplying, add the exponents. 3 plus 4 is 7. 1 plus 1 is 2. 8 plus 4 is 12. And so I have 32x to the 7. Don't mind my squeaky chair. Y squared over 8y to the 12th. Then subtract your exponents. What's 2 minus 12? That would be -10. I realize that. But just think, what's 12 minus 2? And then leave the 10 on the bottom, okay? Exponent always needs to be positive. So just leave the remainder where it will remain positive, okay? So you see I had 10 left over on the bottom. That's where it'll stay positive, okay? So 32 over 8 made 4. X over 7 over no x's wouldn't cancel anything out. So yeah, there was just the letter y on bottom, so y can't equal 0, because 0 to the 12th power, or any power, is still 0. So, and 8 times 0 is 0. So yeah, okay, let's move on. Okay, so when you're dividing fractions, you have to remember that you're going to flip it and multiply. So look, I wrote the exact same thing, but it's now flipped, okay? X plus 2 is now on the bottom, x minus 1 is on top. My x plus 2's end up canceling out, leaving behind x minus 1 over 2x plus 1. All right, so x can't equal -2 from this. And then 2x plus 1, if you set that equal to 0, well, minus 1 over, and then divide by 2, you get -1/2, so x can't equal -1/2 from there. On this one, this second term was not as a fraction, so just throw it over 1, and when you flip it and multiply, now it's under 1. So the factors of 9 that add to -6 are -3 and -3. The factors of -6 that add up to -1 are -3 and +2. So I'm canceling -3's, okay? That leaves behind x plus 2 times 1, so that's just x plus 2 then. And then I have x plus 4 times x minus 3 left over on bottom. And then x can equal -4 right there, or +3 from these two. All right? And lastly, we have 4 factorable terms. Factors of 18 that add up to 9 are 6 and 3. Factors of 8 that add up to 6 are 4 and 2. Then I'm going to flip this fraction. So factors of -8 that add up to 2 are 4 and -2. That's on top, see? And factors of -18 that add up to -3 are -6 and +3. And again, that's now on the bottom, and I'm multiplying. So I have x plus 3's on top that are in common, that can cancel. X plus 4's on top and bottom, they can cancel. X plus 6, x minus 6 wouldn't cancel. X minus 2, x plus 2 wouldn't cancel. So just write it like that. That's what's left over. And then you can't equal -4, -2, +6, or -3. All right, and that's it. That'll wrap it up for this bonus edition of adding, subtracting, multiplying, and dividing rational expressions. I hope this helped. I hope you feel like you understand it now. Thanks for watching. Goodbye.